Hi all, welcome to another video subject DC machines and transformers, and we are on module 2, and today we will discuss about the armature reaction in DC machines. So as we know, the armature reaction is the effect of magnetic field set up by the armature current on the distribution of flux under the main poles of a DC machine. It is called armature reaction. So actually it is the effect of the armature flux on the main field flux. Okay, that is actually the armature reaction. Okay, so as shown in the figure, this is the figure of the main field flux alone. That is the field here. The field winding is energized. That is the north and south pole will be there. Okay, if you are energizing the field winding here, magnetic flux will be generated. Okay, so corresponding north and south poles will be there, and we are assuming that no current is flowing through the armature conductors. Okay, that is generator is supplying no load. Okay, so at that conditions the armature flux will not be there. So this is the main field flux alone. Okay, so this is the ideal case. But if there is a current flow through the armature conductors, then of course around the conductors there will be a magnetic field. Okay, so that is called our armature flux. Okay, so here in this figure you can see the geometrical neutral plane and a magnetic neutral plane. Okay, so geometrical neutral plane is the actual axis of our physical axis of our machine itself, and the magnetic neutral plane. Okay, so it is corresponding to the, it is always be perpendicular to the MMF. Okay, always be the magnetic neutral plane will be always be perpendicular to the MMF produced. That is the resultant MMF here. Okay, so here the magnetic neutral plane is coinciding with the geometrical neutral plane, and the MMF will be perpendicular to that. Okay, so actually this is the direction of the MMF that is actually written here. Okay, the plane through the axis along which no EMF is induced in the armature conductor is known as the magnetic neutral plane. So that is when the conductor is arranged in this plane. Okay, in this plane, in the conductors the EMF will not be induced. Okay, and this is the case of an armature flux alone. Okay, here we are assuming that the field is not energized, but the armature conductor is carrying current. So when the armature conductor is carrying current, we know that of course using the thumb rule there will be a magnetic field around each conductors. Okay, so this is the figure of armature flux alone. Okay, so when this armature flux interacts with our main field flux, the armature flux will weaken the main field flux. So that's our armature reaction. Okay, so when a question comes, you have to draw the first figure, this one, and you have to draw the second figure, that is armature flux alone, and you have to draw the combined figure. Okay, this is the combined figure here. Okay, so here in this figure you can see, okay, you can see the main field flux is distorted. Okay, the variation is very much large in the case of this main field flux. So actually here we can say that the current flowing in the armature conductor creates a magnetizing effect or MMF that acts at right angles to the main field flux. Okay, that is armature flux acts as an opposing, okay, it will opposes our main field flux. So this action is called the cross magnetization. Okay, the armature flux right angles to the main field flux, so actually it distorts our main field flux. That is called cross magnetization. So cross magnetization is present only when the armature current is flowing through the conductor. Okay, and in this figure you can see the flux is distorted here. So when the generator is supplying load, the main MMF, okay, the main MMF is downwards, that is OA here. Okay, downwards represented by the vector OA, and the MMF produced due to armature current is OB, that is it will be right angles to OA. Okay, right angles to OA. OA is the main field MOF and OB is the corresponding MOF produced by the armature current. Okay, so the resultant vector will be OC. The resultant of OB and OA will be OC. Okay, so this is the resultant flux and the resultant MMF. The resultant MMF OC here, and we know that the magnetic neutral plane MNP will be always perpendicular to the resultant MMF. Okay, resultant MMF. So here the resultant MMF is like this. So the magnetic neutral plane will be shifted along the direction of rotation. Okay, in the previous case we have seen that the MNPs coincide with the GNP here, but due to the armature reaction the flux distorts here. Okay, and we know that the MNP will be perpendicular to the resultant MMF. So the MNP will be like this. Okay, lying on this line. This will be our MNP. Okay, and here it is observed that the field strength in the gap, this is the air gap here, this is the air gap, this is the rotor and this is the stator, that is the pole core, and this is the air gap here. Okay, so the field strength in the air gap is weakened under the leading pole tips. Leading pole tips means here we are assuming that the rotation is in the clockwise direction. Okay, rotation is in the clockwise direction. Here you can see that rotation is in the clockwise direction. So the pole tips comes first will be the leading pole tips, and pole tips comes last. Okay, later is the trailing pole tip in the direction of rotation. Okay, so here the field strength in the gap is weakened. Here you can see it is weakened here. Okay, under the leading pole tips, and it is strengthened under the trailing pole tips. This is the trailing pole tip. So under the trailing pole tips it is strengthened. Okay, so mainly because we know that here in the leading pole tips, if you are observing the figures here, in the leading pole tips the direction of the magnetic field is like this. Okay, in this direction. So of course it will opposes. Okay, of course it will opposes the main field flux. The direction of the main field is like this. So here this armature flux opposes the main field flux. Okay, so it weakens here in the leading pole tips, it weakens. But in the case of a trailing pole tips, what happens here, in the trailing pole tips the armature flux direction is like this, that is in the downward direction, and also the main field flux is also in the downward direction. So here the flux aids. Okay, the armature flux aids the main field flux. Okay, so the field is strengthened in the trailing pole tips. Okay, so we can simply understand by looking at the direction of the flux lines here. Okay, so actually that is written here. And with no current in the armature, the flux density in the air gap is uniform. So here this is the uniform normal flux density in the air gap. Okay, this is the direction, that is curve 1. Curve 1 shows the normal flux density in the air gap, but due to the armature reaction, the zero crossing point, okay, it will changes to another point, and this is the actual magnetic flux density curve we obtain under a pole. Okay, that is it will shift from the geometrical neutral axis and neutral plane, and the zero crossing is like this in this point. Okay, so flux density varies as shown in the curve 2 here. So here the magnetic neutral axis will be shifted along the magnetic neutral plane, and the brushes will also shifted so as to be along the magnetic neutral plane to have sparkless commutation. Okay, so here as shown in the figure, when this magnetic neutral plane is shifted, we have to shift the brushes along the magnetic neutral plane. Okay, that is if For instance, the brushes are not shifted to the to be along the magnetic neutral plane and are left along geometrical neutral. Just assume the brushes are left on this geometrical neutral plane. So what happens is actually mm, the coils being short circuited by the brushes, okay, would be cutting flux. Okay, that is, if for instance the brushes are not shifted to be along magnetic neutral plane and are left along the geometrical neutral plane, the coils being short circuited, that is during the commutation period, the coils will be short circuited, that is the current reversal is happening in the coil. Okay, so the coils being short circuited by the brushes are not shifted to be along the magnetic neutral plane and are left along the geometric neutral plane. Here the coils being short circuited by the brushes would be cutting flux. Okay, will be cutting the flux here and would therefore have an EMF generated in them, causing an arc to be formed as the commutator segments move under the brushes. Commutator is moving but brushes are fixed. Okay, so if the brushes are in the geometrical neutral axis, there will be a possibility of sparking. Okay, because actually the magnetic neutral plane is shifted. Okay, so if the brushes are placing in the geometrical neutral plane itself, an EMF is induced in the corresponding coils, and of course there will be a spark. Okay, so for avoiding that, we have to shift the brushes along the magnetic neutral plane. Okay, so actually that is written here. So the armature MOF here is no longer all cross magnetizing in its effect, but is partly demagnetizing in its action. So demagnetizing amount of armature flux results in a weakened field flux, that is, it reduces the total flux per pole. Okay, total flux per pole. But the cross magnetizing component of armature flux distorts the main field in the air gap. Okay, distorts the main field in the air gap. So these are the main effects of armature reaction. How can we overcome the armature reaction? Okay, how can we overcome the armature reaction? So the first method is by flattening of the pole faces slightly so that air gap is longer at the pole tips than the center of the pole. So this results in increase in reluctance. Okay, increase in reluctance at the pole tips, and so in the magnitude of the armature flux will be reduced. Okay, if the reluctance in the air gap is increased, the armature flux will be reduced. Okay, and second method is by making trailing tip of pole longer than the leading tip. Okay, so this will equalize the distribution of magnetic flux. Okay, so actually in the leading pole tips it weakens, and in the trailing pole tips it will be strengthened. Okay, so by doing so, that can be equalized. And the third method is the air gap length may be increased. So if you are increasing the air gap length, what happens is the reluctance of the air gap is increased, so the magnetic flux, that is the armature flux will be reduced. Okay, and also by reducing the cross section, of pole pieces, so it becomes highly saturated and offers large reluctance to the cross field here, that is armature flux here. And last one is by providing the interpoles between the main poles and the compensating winding. Okay, so interpoles means actually in this case we can provide interpoles here in the interpolar regions, that is in between the main poles. These are the main poles, so between the main poles we can provide interpoles, so actually the interpoles will cancel the armature flux in the interpolar region. Okay, interpolar region. And also we can use the compensating winding. So actually the compensating winding will place under the pole faces. Okay, under the pole faces. This is the pole face. So just below the pole faces we can place the compensating winding. So this compensating winding will cancel the armature flux in the polar region, that's just below the main poles. Okay, So these are the main methods, okay, remedies for armature reaction. Okay, so here one more thing is we have to learn, that is the equation for the cross magnetizing ambient and the equation for the demagnetizing ambient. Okay, so if the brushes lie in the geometrical neutral plane, the entire armature reaction effect is cross magnetizing. Okay. However, if the brushes are shifted from the geometrical neutral plane, a part of the armature reaction becomes demagnetizing and the remaining armature reaction is cross magnetizing. Okay. So we are saying that mainly because here the conductors here, that is in the conductors between the angle AOC, okay, AOC and BOD. Okay, so here the armature flux or armature flux is entirely opposing the, okay, just opposite. If that is, if the main field flux is in this direction, so the armature flux due to that conductors in between the AOD and BOB, okay, BOD, AOC and BOD will be exactly opposite to that of our main field flux. So it will just weakens our main field flux. Okay, but the conductor is here. Okay, conductor is here, that is between the AOD, angle AOD and BOC. Okay, conductor placing here. So here the armature flux due to this conductor will be exactly perpendicular to our main field flux. So that will distorts the main field flux here. Okay, so these conductors in this area AOD will cause the cross magnetizing effect, and the conductors under AOC and BOD will cause the demagnetizing effects. Okay, so the equation for the demagnetizing ambient turns per pole ATD is equal to Z theta divided by 360 into IC, and cross magnetizing ambient turns per pole ATC will be equal to Z into IC into 1 by 2p minus theta by 360, where the angle theta, okay, theta is in the mechanical degrees. It is the actual lead of the brush from geometrical neutral plane. Theta is the lead of the brush from the geometrical neutral plane. Actually, that is, this is the geometrical neutral plane. We know that due to the armature reaction, the MNP is shifted like this. This will be the MNP, magnetic neutral plane. So we have to place the brushes along the MNP. So actually this is the shift and this is the angle theta. Okay, so this is the equation for both demagnetizing ambient and cross magnetizing ambient, and here IC is the current per conductor. Okay, so for this question, for armature reaction question, you have to draw at least these three figures. This is the main field flux alone, and this is the armature flux alone. So when this armature flux is interacts with the main field flux, armature reaction occurs and the resultant flux will be like this. Okay, this is the resultant flux. Okay, so due to the armature reaction, the magnetic neutral plane shift like this. Okay, in the previous case it is along the geometrical neutral axis, but it will be shifted like this. Okay, so we have to shift the brushes along the magnetic neutral plane. Okay, so I hope all of you understand the armature reaction well. So thank you.